Hi, and welcome to the ICS 103 programming course. This is lecture number 8, where we're going to be talking about data files, okay? So let's start by giving an outline. And here's an outline of what we're going to talk about today. We're going to be talking about why data files, how we can declare file pointer variables, opening data files, scanning and printing data files, closing a data file, and then we will talk about printing versus echo. Finally, we'll talk about handling files that are not found and the end of file controller. Okay, the EOF. So here it goes. So the first thing I start with is why we have data files. Okay, why do we ever have data files? So suppose that we are making a program and we want the program to be running for a year time. For example, making the payroll of a company. So what you want to do at the beginning of the year is put the names of the people and put their pays in each payroll, and the payroll system then automatically generates a check or does a transfer of a money, whatever type of payments being made. It does it automatically at the end of the month. Okay, so in this case we actually don't want each time the user running the program to actually go and enter the name of each user and then how much he's going to be paid, so that the program is going to print his check. Okay, so this is what we don't want to do, and to do that, what we have to do is we have to create a data file. Imagine if you had a company that had 5,000 employees, and each month you have to enter the name of the employee and his salary. That will make life very difficult for you. Okay, so in many real life applications, the input data is so much that it will be convenient to expect the user to type it that will be inconvenient to expect the user to type it each time a program is going to run. And I gave you the example of a payslip. Okay, similarly, there are many applications where the output will be more useful if it's stored in files rather than screens. Okay, so suppose you're working on a research and you want to generate an output, and the output is just numbers, and you want it to be put in a specific format so you can actually open it in a program that can actually manipulate this data. So you want to write it into a file so that that file can be opened by another program, and then it can extract the data in it and do some more calculations for you on it. Okay, maybe draw charts or something else for it. Okay. Good news is that C allows you to do that. You can actually write into a data file and read from a data file. Okay, so that's the good news. You have data file capabilities in C. So the procedure and how we are going to go into data files is that first of all we'll have to declare a variable of type file. Okay, so this is the variable type, and it's a capital F, capital I, capital L, capital E. Okay, all in caps. You have to declare a variable of type file, and this variable is basically a variable into the memory of the computer that is basically responsible at pointing to a file. Okay, then you actually do an open file, and to open the file you actually use a command fopen, and we're going to talk about the details on how you do that. Okay, then you have to read and write from the file. To read from a file you use the function fscanf, and to read and write to a file you use the function fprintf. After you finish with the file, you have to close the file. So these are the four main steps that you have to do. You have to declare a file pointer, so you're capable of pointing at a file. Then you have to open that file, so you can actually read and write from it. Then you have to read and write into it, read or write, and then you have to close the file at the end of your program. Okay? So let's go in each step in details, and let me tell you how you actually can go working with files. So we declared the first step is that you want to use, or when you're using files, the first step is you want to create a variable of type file. How will you do that? This is how would you do it. You actually say file, then you put the strike and the name of the file or the variable that you want to name. Okay, so for example, in our old programming styles we used to say, if you want to declare an integer x, we say int x. Okay, this is similar. So you put the type first and then the variable name. Over here the type is a file, and you have a capital F, capital I, capital L, capital E as file, and then you have to put the strike sign to indicate that this is a pointer, and then you make an in file. Okay, so this is the file name. You can name it in file, you can name it in, you can name it ABC, you can name it XYZ, whatever name that you want. Okay, in this example we are declaring two file pointers. One file pointer is in file, and then comma, the second file pointer is the out file, and the compiler stops at the semicolon, the extra spaces, and this is going to be ignored because this is a comment. Okay, so this is actually declaring two file pointers. Okay, why do we have to make it a pointer? That is a very common question that I used to get from students. We have to make it a file pointer because the file actually exists on the hard disk. Okay, so suppose you are working on the grades of a student, so you have a file that contains the grade of students. Okay, so that file is going to be basically stored into the hard disk. Okay, so if I just explain it over here, the file is actually stored into the hard disk. It is somewhere in the hard disk, the file that contains your data. You are working into the RAM of your computer. Okay, so sorry, RAM of your computer, and you have to declare over here a file pointer. So if you say file pointer in file, you create a variable, and this variable is capable of pointing at a hard disk where your data is. Okay, it's not gonna point until you open a file, but you have to declare a file pointer like in any variable in C. You have to declare it first. So you have to declare this variable so you're capable of in the future pointing to a hard disk file. Okay, so this is a file pointer. You declare, you allocate a memory into the RAM so you can actually point to the file so you can actually read and write from it. Okay, so this is in file. This is a file point. The variable name is in file, and it's a type pointer, and it's a type of file, and capital F, capital I, capital L, capital E. Be sure that you write it in the same case, all caps. Okay, so over here we declared two file pointers, and these two file pointers are capable of pointing to a file. Okay, then so I talked about the strikes. Then what we basically have to do is, let me just open to the next page. After you have declared the file pointer, you have to open a file. Okay, so before we open a file, we have to know the types of file. Okay, because C can only, we are teaching you to deal with a particular type of file, and there are other type of files that we will not teach you in this course how to work with, and you can learn them on your own convenience in the future if you like to. Okay, so there are two basically types of file. There is a text file and there is a binary file. What is a text file? It's a file that contains only characters, usually ASCII values, so it has characters or letters or alphabets as you can imagine them when you open any text file, and that can process sequentially in forward directions. Okay, so in any text file you always do processing sequentially in forward direction. Okay, so text files are files basically that do not have any formatting. Okay, there is no bold, there is no italic, there is no make the size of the font this big, make it this small. No, it's all universal. It's only one size. It has only, you can only type into it letters and characters and things that you can actually type onto the keyboard using an ordinary keyboard in any computer, and they are usually stored in ASCII values. This is called a text file. Okay, there are special characters in it called the carriage return, or when you press the enter key you have the carriage return, and in computers or in C we usually denote to it to /n. Okay, there's also the line feed special character for a new line. Okay, so you have the carriage return, line feed special characters. These are characters that are automatically inserted into your file at the end of the line. Okay, so when you are writing in your text editor, so if you open your text editor and you start typing something and you press enter, you see your cursor going from the screen from the end of the line to a new line, whereas you don't see anything over there. There is a hidden character over there called the end of the line character, okay, or the carriage return or the line feed, whatever you want to call it. Okay, that character tells the program that the line has ended and you have to go to the new line, and then you start typing the second line. When you finish, you have to put a carriage return or an enter key, so you put an end of line character over there, and then you come back over here. So each line that you actually see has an end of line character in a text file. Okay, at the end of the text file, to indicate that the file has finished, you have an end of file character, and we're going to talk about that in details in the coming few slides. Okay, the other type of file is the binary file. A binary file is no different from a text file. It is a collection of bytes. Okay, so in binary files there are bytes in it. There is data in it that is usually not readable by humans. Okay, in a C, byte and characters are equivalent. If you are using a text file, you want to use Notepad or any other text editor to create text file. In our course we will use Notepad because it's readily available in Windows, and we're going to be talking about text file, and we always name a text file a name. This is an example XXX. You can say it ABC, John, Khalid, Muhammad, whatever name that you want, .txt, and usually a text file has the extension .txt, okay? So that indicates to the user that this is a text file. We can actually open it and read it, okay? So here's the difference between text files and binary files. So binary files are files when you open them you cannot read them. It's for the computer to use. This contains sometimes the machine code or some data that the computer is saving. Text file, on the other hand, is something that we can actually write and read, and we can open and take the data from. Now, since we know the types of file, I told you that we first declare a file pointer type. So we'd say file, the type of variable is file, and then we pointer in file, so we can actually point to a file. And over here, after you do declare the file pointer in file, you have to open the file. You have to tell the compiler which file into the hard disk you are actually intending to open. So you use a command called fopen. And the fopen command, this is how it goes. You write the in file, so the file variable, the pointer that you have actually declared, you say that. If you said in file, so you say in file equals to fopen, and between brackets you give it 2 arguments. The first argument is between double quotes, as you can see, so you have double quotes over here. You give the file name, okay? So this is, for example, data.txt in this example. So you're asking the compiler to go to the hard disk, look for a file called data.txt. It's going to look for the file data.txt and open it with the second parameter input. The second parameter input between double quotes you have R, and that signifies that it is the file you're going to open it for read-only purposes. So you're asking the compiler to open a file using an fopen. The name of the file is data.txt, and I want it to be read-only file. A read-only file is a file that you can actually read data from, but you cannot write to. Okay, so you can take data from it, but you cannot write to it. If you wanted to open a file for writing, so the other example is over here is out file is equal to fopen, and in between brackets you give the file name result.txt and you give it w. That signifies that you want a file that you want to go and write data into. Okay, so R for read and W for write. Now, when you open a file using this command, the fopen data.txt, the computer is going to go and look in the hard disk for a file called data.txt. Now, where is it going to look for the file? It's going to look for the file in the same folder where the executable is running. Okay, so if it's on the desktop, you have to have the file on the desktop. If you have it in C, you have to have the file in C. If you have it in another folder, you have to have the data.txt file in the same folder where the exe is running. It's going to go and attempt and open that file. If it finds that file, it's going to open it and return a valid pointer to the in file. Okay, so the in file then will point to your hard disk, and it will actually be capable of opening and reading that file. Okay, so here's how it goes. So if you have a hard disk, in the hard disk you'll have data.txt. Okay, this is your file. So in your RAM over here, you actually declare an in file and you make it point to the hard disk where the data is actually stored. Okay, so when you declare a in file, you're actually allocating the space into the RAM, and when you do an fopen, you are actually pointing to the data file that is in the hard disk. Now, there are many possibilities. One of the possibilities is that you actually can find the file, so you're going to open it and you start pointing at it. The second possibility is that you don't find the file in the folder where the exe is running. In this case, the compiler is going to return into the in file the value null. Okay, capital N, capital U, capital L, capital L. Okay, null means that the compiler is telling you, hey, Mr. Programmer, I could not find the file in the hard disk. That is why I'm putting null into the file pointer. So I'm pointing at nowhere because I couldn't find the file, so I cannot point at anywhere. Okay, so I'm pointing at null. Okay, so it will return null if it was not capable of opening a file. Okay, when will it not be capable of opening a file? When it cannot actually find it. Okay, so if the file doesn't exist and you forgot to create the file or copy it from somewhere else to that folder, then it's going to return a null, and you have to handle this case, and we'll tell you how to handle this case in the coming few slides. Okay, now when you open a file for write, the compiler what's going to do, it's going to go into the folder where the exe is running, and it's going to create a file for you called result.txt if the file doesn't exist. Okay, if the file doesn't exist, it's going to create a result.txt because you ask it if it's a file for writing. So it's going to create it, and it's going to open it for you and point to it so that you can actually, when you write into it, you can actually write into the hard disk of the computer. Now, this is usually a command that never returns null. It will only return null in the case that your hard disk is completely full. So if your hard disk is completely full, your compiler is going to go and attempt to open a file, and since the hard disk is full, it will not be able to open it, and then it's going to return a null character and put it into the out file. Okay, so this is the only case where you will get a null. There is another case where you might not have permission to write on that hard disk. So if you did not have a permission to write on that hard disk, it's also going to return a null. So whenever you cannot open a file for write, you will have a null into the output file. Okay, so this is basically what this slide signifies and how the operation is going. Then we come to the point of where we want to actually read and write to and from the file. Okay, so we actually declared a variable, we pointed it at the hard disk, now we want to read and write from the file. To read from a file, you use an fscanf, and the fscanf is nothing but something very similar to the scanf, with the difference that the first argument that you give between the brackets is the file name. Okay, so you say fscanf, so I'm actually asking the compiler to do a scanf on a file. So this is file scanf, fscanf. Go read from a file. The file is pointed at by infile, so it's going to go to the infile, the file that's pointed by infile, which is data.txt, and then I'm going to ask it, then comma, and between the double quotes I have %lf and the address of miles. This is exactly the same as the scanf. And I'm actually asking it over here to read from me a double value and store it into the variable miles that I already have declared in my program. Okay, so the fscanf actually works similarly like the scanf. So if you actually hide the f of the scanf and hide the file name, this is actually a scanf. To convert it to a this is actually asking the user to read a number and store it in miles. If you want to read from a file, what you have to do is you have to put the f in front of scanf, and you have to put the file name at the beginning, so that you can actually tell the compiler that, hey, I don't want to read the input from the user, I want you to read the input from a file, and the file is pointed by the infile. Okay, and similarly, if you want to write to a file, so you say fprintf, and similar to the printf, with the difference that you put an f in the beginning, and in the bracket, between the brackets, the first argument that you put is the file that you want to write to. Make sure that you have capability to write onto this file. Do not write onto a file that is read-only. And in this case, when you say fprintf out file, it's going to go to the out file and write whatever is between these two quotations, just like the printf. It's going to say that equals to, and you have %2f. It's going to take the value of the kilometers, 2 decimal places, and put it and then kilometers. Okay, so the fprintf is similar to the printf, with the differences that you put the f, so you indicate to the compiler that you're reading from or you're writing to a file, and then you give it the file that you are actually writing to. Okay, now there is one thing that I actually forgot to state over here, and that is that if you open a file, result.txt with w, and the file already existed on your hard disk, what's going to happen? Okay, so if the file is already there and you open it with w, it's going to override that file. So any data that is inside that file is going to be deleted. So make sure that you do not need the data that is inside this file before you run your program. Okay, otherwise you're just going to override the data that is in it, and you will lose any previous data that was stored in it. So now coming back to the fscanf and fprintf, the fprintf is the same as the printf. You have to give the file name, and then the rest of it is equivalent to a printf. Okay, so fprintf and fscanf and all the other things that are concerned about the file are in the stdio.h header file, or into the directive include #include. You have to #include the stdio.h, so you can actually use the fscanf and the fprintf commands. Okay, then when you finish working with a file, you have to do an fclose, and fclose, you say fclose, and between bracket you give the file name that indicates to the operating system that, hey, I have finished and I want you to close that file for me. Okay, now why do we have to close a file before we actually close our program? Okay, so I'm going to over here explain in details now what file opening basically does. So when you declare a file pointer, you actually go to the RAM, okay, and inside the RAM of your program, you're going to allocate a variable which is capable of pointing to a file, correct? Now when you open a file, you basically don't go and point to the hard disk directly. Remember that we have the operating system, and the operating system is always sitting in the middle, okay, and your hard disk is over here. So your file data.txt is somewhere in the hard disk, okay, so you're opening data.txt, for example. Okay, so what you do is you go and ask the operating system to open this file. So the operating system is going to go look for this file, and what opens, it's going to create a buffer for you, okay, and it will be pointing at this file and you will be pointing at this buffer. And this is actually what happens, because working with the hardware is the responsibility of the operating system. You do not work with the hardware, the operating system does. So when you actually in the RAM go and ask the operating system to open a file, you actually point at a buffer that is in the operating system, and then it actually goes and reads and writes data to the hard disk. Now when you do an fprintf or for example, in an output file, if you're doing an fprintf, you actually write into this buffer, and then the operating system then goes and writes to the hard disk. Okay, now when does the operating system write to the hard disk is something that you will never know, okay, because that's operating system dependent. Writing to the hard disk is a very lengthy procedure for the operating system, so the operating system don't tend to write the data as soon as you write it onto the buffer of the operating system. That is why you have to close the file. So when you close the file, you basically are telling the operating system, hey, I finished, please take any data that you have buffered in your memory and put it into the hard disk and close it. Okay, so you basically put that into the hard disk, and then you delete your program, so the operating system is going to delete this buffer, so it's not going to be pointing at that file anymore. So this is why we need an fclose, so that we actually can tell the operating system, hey, I have finished. If you have kept something in your memory and you did not write it into the hard disk, please go and dump it into the memory of the hard disk, so that, and then clear my buffer, I am finishing my work with this file. Okay, the same thing with the open file. When you open a file, you actually are pointing at a file that is on the hard disk, and you are pointing at a buffer. So you read, when you read from it, the operating system reads from the file and puts it into its memory, its buffer, and then you actually read from that buffer. That's exactly what's happening. So when you read from the buffer, you might have the buffer allocated in the memory, so when you are finished reading from the buffer, you close the file to tell it, okay, please go ahead, close that file and delete that buffer for me. Okay, so this is what's going on into the hard disk, and this is why we use an fclose and fopen. Okay, it is a common error to forget fclose. This is a problem, especially for output files. The system may delay writing the data output files until they are closed. Okay, so you don't know if this one the operating system is going to write. Maybe it's waiting for a specific file size. So for example, it has to write 1 meg and then it's going to write it, for example. So unless you enter 1 meg, it's not going to write it. So if you enter about 3 letters, it's going to keep it into the memory and not write it until you reach 1 meg. Or you tell it, I'm going to close this file, so it's going to take the 3 letters that you have written and put them into the file. Okay, sorry about that. Okay, it is possible for a program to open a file for output, print some result, close the file, and then open the same file for input. Okay, so you can close and open a file as much as you like in C programming. Okay, here is an example, and we're going to go in details in the example of what the computer basically does when you are dealing with files. Okay, so the example is we want to convert miles to kilometers using a data file. So I have a data file which has a single entry data in it, and I want to convert that, and I know that's in miles, and I want to convert it to kilometers. So I start with my hash directives, and I define kilometers per mile as 1.609, and then I go and int main void, and I declare my variables double miles and kilometers. Okay, so if I go to my memory map of my function, I will have the main program having a memory into the main, and inside it I will have KMS as a double. I will have miles as a double, okay, and then I will have file pointers in file. Okay, I indicate an out file, and that will be the memory that I will be allocated from the operating system. Okay, so inside it I declared two variables that are type of double and two variables that are type of pointer. Then I say in file fopen data.txt, so I'm actually going to be opening a file. So there's a hard disk over here, and inside the hard disk there is the file called data that has the data that I'm going to read, and it has, and I will use the in file pointer to point at the file that is actually coming from inside the hard disk. Okay, there's another hard disk, another file over here is going to be created for you, and that file, okay, is out file, because you say out file fopen result.txt w, so it's going to go create that file and actually point to it. Both of the files are in the hard disks, okay, and you are actually reading and writing on the hard disk. You have the operating system in the middle, but I'm not going to show you that now. Okay, so in file fopen data.txt, you're going to go into the hard disk on the same folder that you are. You're going to look for the file data.txt. If you can open it, you're going to return something to this, and you start pointing at it. And this is for W, so you're just going to go to the hard disk, open a file. If it already exists, you're going to delete it, open a new file, and you're going to start writing to it. Okay, then you say scanf in file, so I'm asking it to scanf from the file. So read from the file in file, go to the in file, read from it a double, and store it into miles. So it's going to go to the in file, there will be a number stored in the data.txt, and come and write it into miles. So suppose that this was 1. Okay, so I put 1 mile, so I'll have 1 written into my miles when I conduct this line of code. Then I say fprintf out file, so in the out file I'm going to print the distance in miles is percentage point to f. Okay, and I'm going to take the value that I have in miles and I'm going to put it into the output file. This line is called an echo. What is an echo? Echo is known in physics when you speak something and the sound reflects back to you back again and you can hear it again. That's called an echo. Okay, and this is an echo. What we are doing, we're taking the input that is from the data file and we're writing it the same thing as in the result file or the result.txt file. Okay, why are we doing that? Because we don't want the user to open the output file and then just have a number. We want to tell him that we have read this number from the input file and now we're going to convert that number into kilometers. Okay, so that is called echoing, and this line is over here is echoing. It's actually taking the input from the in file and writing it into the out file. I did not do any calculations here, notice. I'm just echoing it. I'm taking the value, I'm just putting it into the out file so that the user, when he opens, he can actually find the miles and the kilometers next to it. Okay, so this is the miles and this is the value of kilometers next to it. So I'm going to write this down into the output file, and this is called the echoing procedure. And then I'm going to do the calculations, and I'm going to calculate the KMS, and I'm going to use the constant that I have, and I multiply by miles over here. In my example, it will be 1.609 because 1 multiplied by any number will give you the same number, and that was going to be stored in KMS. And then I fprintf, so I go and ask the computer to do another printf into the out file. So I'm going to go to the out file, which is the result.txt, and say that equals to percentage point to kilometers. So I'm going to take the value, which is 1.61 over here, and store it into the kilometers into the output of the result.txt. Okay, so I took the input from a file, I echoed it to a output file, I calculated my result, and then I put the result into the output file. Then I close my file, so I actually go and tell them that, okay, so delete this, and then return 0 to end my program. Okay, so now after I run this program, I can go to the hard disk of my computer where the executable is running and open the result.txt, and inside it I expect to find the distance in miles is, and we'll have an echo of the number that you actually put into the data.txt, and then we have that equals to the conversion of that to kilometers. Okay, so the user has full visibility of what's going on. Okay. make sure that before you run this program, you run Notepad or any text editor for that matter, and you create data.txt and you put a number in it that you want to convert, okay? Otherwise your program is not going to run. Okay, so in the last example, the fscanf gets the value and we actually print it. So I talked about the echo and print, so I'm gonna skip this slide so we know what the echo actually does. And this is the echo, okay, the distance in miles. So you read a value and you write it, and that is called the echo. And then we're gonna talk about handling file if it was not found. So what happens if a file is not found? Okay, when the file is not found, the compiler returns a null and saves it into the variable that I have. Okay, so the in file, for example, I do an fopen in file. In file is equal to fopen data.txt in R, and suppose that data.txt did not exist on my hard disk in the folder that I was running, so I'm going to be returned a null value. So I have to do after that a check and a say if in file is equal to null. So if you could not find the file, so you search for the file on the hard disk and you couldn't find it, it's going to return a null into the in file. If in file is equal to null, that means you did not find the file. Printf, sorry, input file not found. So you can put any print over here. You can actually print the file name or whatever you want to print, but something to tell the user that you could not open the file, and then you say exit 1. Okay, what does exit 1 do? Exit 1 terminates the program. And why do we use exit 1? Exit is a special command in C that you actually use to tell the operating system, hey, I am exiting my program from the middle, and I'm exiting it because I want to exit it with the code number that is between the brackets. Okay, now you can program the operating system to actually do stuff with exit with the number that you have put over here, but we're not going to teach you that in this course. Okay, so this is basically why we use an exit. An exit stops your program, it terminates it, it kills your program. You don't continue. Okay, so as soon as you hit exit 1, you stop. That's it, finish. Okay, your program is going to stop and it's not going to continue. Okay, you should call it with the argument 1. This tells the operating system that the program stopped due to an error. Okay, so there is an error that occurred, that is why it stopped. 0 used with return 0 indicates that it was a successful run. Okay, you can actually put any other value, then you have to set up the operating system to work onto that value. Okay, so here's the final example that we're going to give, the complete program of converting miles to kilometers. You will go the same way, declare your variables and your file pointers, then you open the file, and then you check if that file is open or not. If it was not open, you say sorry and you exit, and your program is going to stop. If the file was open correctly, you're going to jump the if statement, you open the output file. We usually don't check the output file because nowadays you have a lot of space into the hard disk, so it will not constitute any problem, and we think that you will be an administrator on your computer if you're writing C code. Okay, so you'll be actually running a program, so you can actually open a file for write very easily, then you can read that and then echo it, calculate the kilometers, put it into the output file, and then close all your files. Okay, now the end of file controller, this is the EOF, this is the end of file controller. Okay, the last example reads a single value from the input file. This can easily be provided by the user. Okay, so this is very easy. A more common application is that you have a file that has hundreds or thousands, maybe millions of numbers, and you want to convert them. Okay, so what you will basically do is you actually read from the file number by number and you do it. How would you actually know that the file has ended? Okay, so this is an example. For example, finding a class average from grades of students in a quiz. So I have somebody comes to me and say, hey, I have a number of students. He didn't tell me how many students he has, and he wants me to calculate the average for the students. Okay, the grades are normally stored in an input file, and the program needs to read them one at a time in a loop until all of them read and add to the sum variable. Okay, so you actually go open a file, and what you do to calculate the average, you read the first number and then you actually store it in the sum, then you read the second number, add it to the sum, and the third number, then add it to the sum, and the fourth, and then the fifth, and the sixth, and the seventh, until you finish the grades of all the students, and then you actually have the sum that you have over here. Then you divide it by the number of students to get the average. Okay, The question is, how many times should the program scan for these values? Okay, how many times should I read? Because I don't know how many students are there. Okay, we may use counting loops if we know how many students are there. Okay, so if you know there are 30 students, you can use a for loop and say I equals to 0 and I less than 30 and I plus plus, and read fscanf in the for loop, and you read it 30 times, so you know exactly how. But most of the time we don't know how many students are there. Okay, so what we'll do, the good news is the fscanf returns a special value called the end of file. So the fscanf, when you read, here's how the fscanf works. It goes to the file, and if you do an fscanf and you read a number, it's going to give you the first number. Okay, after you read the first number, so let's take an example over here. So suppose you have a file which has 1, 2, 3, 22, 7, and that's it. So when you do an fscanf %d, it's going to read the first number and store it to the variable that you tell it to. Okay, then if you do the fscanf next time, it's going to read the second number. So once you read the number, that's it. You cannot come back to it. You have to go to the next number and take it. Okay, so you take the next number and you scan. When you do the third fscanf, you get this. When you do the fourth fscanf, you get this number. When you do the fifth fscanf, you get this number. When there are no more numbers left and you do an fscanf, it's going to return for you an end of file, EOF. Okay, that means, okay, the file ended. I don't have any more numbers. Okay, so when the fscanf returns this, it's a good way of checking. So you can actually check if this fscanf returned for you an end of file. That means you finished the file. That means all the values that are in the file have been processed, and that means your program should stop. Okay, so it gets out of the loop. So this is good. So when it encounters end of file, no more data values to be read. So we can take advantage of this, and we use end of file controlled loops. And how will we do that? So here's the example. And in this example, we would like to calculate the average score in the class quiz. So we have our hash includes the directives, then in the main we declare a file pointer in file. You can name it in, you can name it ABC, whatever file name that you want. And then you declare your variables double score, sum 0 and average. And you declare a counter and input status. So you say in file is equal to fopen scores.txt and r. So you actually are opening the file called scores.txt for read, and you are assigning the pointer variable for the score.txt. So the in file is going to be pointing at the scores.txt file. Okay, then you say input status is equal to fscanf in file %lf and the address score. So what you did is over here you ask the function fscanf to go for the in file, read a single double number from it, and store it in scores. So it's going to go to the file, read the first number that is over here, and store it into scores. Okay, and it's going to return for you an end of file if it reached the end of file, and it's going to return for you the not end of file if it did not reach the end of file. Okay, so the value of input status will be not the end of file because I actually read a number from the file. Okay, so then you can check over here and say, is input status is not equal to end of file? If it's not equal to end of file, I want you to go over here and do the calculations for me. That means that you got a valid number from the file. So I want you to over here printf the score for me. So you echo it onto the screen so that the user knows what I'm doing. And then you say sum plus equal to the score. We initialize the sum by 0. Why by 0? Because we're going to do an addition, and we have to initialize it by the identity of the operation that we are doing. So we initialize it by 0. We add to it the score, and we come over here, increment our counter. So we initialize the counter by 0 because the counter is counting how many students I have in this class. And then I actually read again. So I say input status equal to fscanf in file, go to the in file, read another number, and put in score. So it's going to go and read another number. So next time it's going to get 3.5. It's going to get the 3.5, put in scores, and then you're going to go back into your loop and check. Is the input status not equal to the end of file? Since we read it, this is going to become true. You're going to come again. You're going to add the number to the score. You're going to increment count. It's going to become 2. Then you're going to read the third number. So you're going to return with 2.0. in scores. Okay, so 2.0 is going to come, and then you're going to go on, take the next number, next number, next number, until you come to the 10, which is over here. You're going to read the 10, you're going to come over here, add the 10 to the sum, and then increment the number of counter by 1, and then you're going to read another number, so you're going to get the last 10, and you're going to come over here back again. So the input status is not the end of file until this is true, and you go and add it to the score, you add it to the count, and then you're going to read again, but you reach the end of the file. Since you reach the end of the file, this is going to have a value. The fscanf is going to return for you a value end of file. So is end of file not equal to the end of file? this condition then will become false, and you are going to jump out of the while loop. See how we actually read all the numbers that are in the file, and then we jump out of the loop using the end of file that the fscanf returns. Okay, so the fscanf returns the end of file, and it does not store it into the variable. Okay, it returns the end of file. So after we finish, we calculate the average, which is the sum of the scores that we calculate over here with the number of students that we have in the count, and then we can actually print the sum, the average for the user, and then we can close the file, and this is exactly what the user is going to see when he runs this program. Okay, a more detailed illustration of how the program is actually running and how the while loop is going is into the slides, so please go into the slides and you can have a better understanding of what's going on. Okay, so the same explanation that I explained over here, but that is more visual, so go to that and you might be able to understand something visually much better. Okay, with this we come to the end of our class, and I hope you actually enjoyed it. We covered the data files over here, and hope to see you next time on the next lecture. Bye bye.